Okay, so we're going to finish up where we stopped last time with adding and subtracting radicals and learning about combining like terms. This is section 1.3 out of the second semester. Okay, and I'm already printed off. We're going to finish this section up today pretty quick. And I've already printed off section 1.4. So we're going to get into multiplication and simplification of radicals and stuff like that in just a little bit. I'm not going to spend a lot of time explaining how to do these problems so much, because the last video that we did, I spent quite a bit of time explaining how this is more like if you think of it like terms, like if you had this situation here with 2x, 3x, 2x, just like this, instead of the square root of 6, try to shut that out of your mind and focus in on just thinking, okay, this is a like term, this is a like term. So if I had 2 take away 3 take away 2, I'd have -1 here. Take away 2 more is -3, so that would be a -3x, because the 2x and the 2x would cancel. So it's -3x. Same situation here, the 2x and the 2x cancel. The answer is -3 square root of 6, and pretty much done here, because the 6 cannot be simplified into a perfect square. It's just 2 times 3, which is not like there. So now if you'll notice here, we can't say 2 times x plus 3 times x plus 2 times x. So we got a different situation here. So we're going to have to make everything pretty much form into the square root of 2 here. So we've got to figure out how we're going to get the square root of 8 and the square root of 18 to turn into the square root of 2 somehow. So we're going to rewrite this. So you could rewrite the square root of 8 just like this. You could say the square root of 2 times the square root of 2 times the square root of 2. 2 times 2 times 2 is 8. So you could just spread that out, and you can see how there's a square root of 2 that we're going to have left over, because this is a perfect square. 2 times 2 is 4, and the square root of 4. The square root of 4 is 2. All right. And so now this turns out to be, that first term turns out to be 4 square root of 2. Well, the second square is already done. The second term is already done for us. We don't have to worry about that guy, because he's already a square root of 2. And then we talk about the square root of 18. So we're just going to break this down. Obviously, we got the square root of 2, and then we have, now 2 times 9 is 18, right? So if I do 2 times 3, which is 6, and then times 3 again, which is 18, these are all the prime factorizations of the number 18. 2 times 3 is 18. So I've got the square root of 2 there, and I've got the square root of 2 on that second term, just like that. So now, if you'll notice, I've got a perfect square. 3 times 3 is 9. The square root of 9 is 3. So this is going to be -6 square root of 2. And then now we take this, just like we did a minute ago. Think of it like x's. 4 plus 3, take away 6. 4 plus 3 is 7. Take away 6 is 1. So the answer is 1 square root of 2, or in other words, a better way to write that would be just square root of 2 and done. Okay? So all of this simplifies out to be just the square root of 2. Now we can prove that on the calculator real quick. Let's see. Second mode clear every time on your TI-84s. So 2 square root of 8, and then plus 3 square root of 2. And then minus 2 square root of 18. We get 1.414213562. And the square root of 2 is exactly the same thing. See that? So that proves that those two are equivalent. Now, I'm not going to do too much explaining on this, because we want to try to get through this section and move on to the next one. Although we do need to understand the material. We just need to get more comfortable with it. And the next section is going to help us get more comfortable with this type of stuff. So now adding, I will say this, adding and subtracting square roots is probably much harder than multiplying or dividing square roots. So you just got to kind of watch out for. Now I'm going to rewrite this a little bit differently. If you'll notice, I've got a square root of 5 here. That's kind of an oddball there. All right, so we've got the square root of 2 and the square root of 2, just like that. So these terms are going to be put together. All I have to do is figure out what's going on here. So I've got 3, and then the square root of 9 is 3. So 3 times 3 is 9. And then this guy right here is kind of a loner. You can't really do anything with him. I'm sorry, that's the 2 right there. All right, so what we're going to combine here is 9 and 2. 9 take away 2, which is 7. Square root of 2, and then plus 2 square root of 5. You're going to see this on the ACT quite a bit, how to simplify square roots. And matter of fact, you're probably going to have some problems where this is only a part of the problem. This is like how you may have a much larger problem, and then this be the last thing you have to do. So, all right, so let's look at this real quick. It says the key to simplifying will be to organize the radicand into perfect cubes. Now remember, the index is the number above the radical to the left. It's kind of like a superscript. And then right here underneath the radical is the radicand, okay? And so 48 is the radicand, and 162 would be the radicand. So I'm going to read this again. It says the key to simplifying will be to organize the radicand into perfect cubes. In this case, why would it be perfect cubes? So let's look closer at this and zoom in on this and clear it up a little bit. Look at what's different about this problem and this problem. This right here is an understood index of 2. So when you square root something, it's an index of 2. When you cube something or cube root something, it's an index of 3. So in other words, 3 numbers multiply to make 48. Those now here's what we have to do. We need to separate this out into perfect squares. So the best way to do this is to think of it like this. So if you think 48 is equal to 6 times 8, and then just take 6 and 8 and separate those out accordingly. It's much easier to kind of visualize what's going on here when you do it a little bit like this. So you've got you've got a prime factorization of 2 times 3, which is 6, and then 2 times 2 times 2 is 8, right? So do you see 3 of something? So if you'll notice right here, you've got 3 square root of 2's, right? So square root of 2 times, the cube root of 2, cube root of 2, cube root of 2, right? So I'm going to simplify this section. Remember yesterday, I think it was yesterday or the day before, I told y'all to take a big problem and cut it down into small sections. Well, we haven't gotten to the second portion yet, so I'm not worried about the second half yet at this point. So I'm just going to rewrite this. Now I know these two things right here are going to have to stay the cube root of 6, and the reason that is because I don't have 3 2's and I don't have 3 more 3's. I have 3 2's here, but that's all I can use to get pull that cube root out. So I'm going to rewrite this part here to make it look a little bit neater. If you'll notice here, we've got 2 to the 3rd power. So 3 divided by 3 is 1, right? So I'll actually write that out. So we've got 2, think of it like this, 2 to the 3 divided by 3. That's how that's written. And then that cancels out. So our final, a part of our final solution will have this situation here, which this is going to be 2 times 3 here. That's 6 cube root of 6. So in other words, the first half of your problem is going to have 6 cube root of 6. We simplified that down to this, okay? I know there's a lot of steps involved here, but and it's a little bit overkill, but you needed to see the prime factorization and how that relates. This is the first time some of you are seeing this. So I wanted you to get comfortable with what the steps are here, and then we'll start shortening up the steps here in a little bit. Like you didn't really need this step here, to be honest, or this one. You could have gone straight from here to here because the cube root of 3, the cube root of 2 cubed is just 2. You could have skipped these whole 2 steps, all right? So now let's go over here and work this out. So this is going to be 2 numbers multiplied together, 162. Trying to think of some numbers that make 162, so it would be 81. 81 times 2, you could do something like that. And now we're going to separate this 81 out into its prime factorization. So we've got 81 is 9 times 9, right? All right, so we've got 9 times 9 equals 81, and this 2 is left off to the side. So now what I'm looking for is 3 of some object, and I only have 2 9s here. So what I'm going to do now is I'm going to separate the 9s out into 3 times 3. Now you can see how there's going to be 3 3s somewhere in here. All right, so I'm going to circle that. Now I'm going to shorten this step up right here because 3 to the 3rd power cube rooted is actually 3, okay? So this big box would be 3, and over here to the right, we've got the cube root of 6. Now, if you'll notice, we've got like terms here, right? Cube root of 6 and cube root of 6. All you have to do is take 6 and subtract off whatever this is. This is 6. So guess what? This answer right here is equal to 0. All right, how do I know that? Because 6 take away 6 is, let me rewrite this. So when you have this situation, the answer is going to be 0. Okay, so that's a lot of work just to get to the answer 0 there. Now there's much easier and faster ways to do this. You can actually skip a lot of steps here, but there's other tricks that you can do with these square roots. These cube roots that help. But we'll get into that later when you've had more experience with this. Okay, so now it says right here, there are different paths to simplifying. An easy first step is to combine like terms, then simplify the radicand. So that's what I'm trying to get at up here is you can do a couple of tricks here. So here's one of the tricks that you can start off with. If you'll notice, before we even start, you don't have to do the same thing twice. You can just combine 2 like terms before you start. So if you notice you got -3 and +2, that's going to be -1 cube root of 40 minus 2 cube root of 6. See, it's already a little bit more simplified here. Now, at this point, we need to figure out if there's 3 prime numbers that that are part of 40's prime factorization that I can pull out, and if there's 3 6s, but there's not going to be. I mean, this is going to have to stay the way it is. All right, so let's go over here and simplify out. Now, if you'll notice, I put a -1 there. I'm going to leave that 1 off. It's understood. All right, and then if you'll notice, 40 is 2 times 20, right? So the cube root of 6. So what we're going to do is simplify out the number 20. So I'm going to do this a little bit, basically all at once right here. So if you'll notice, 20 is 2 times 10. And then 10 is 2 times 5. All right, and then this is just 2 times 3, so I'm not going to change that. That's going to stay cube root of 6. If you'll notice here, I've got 3 2s inside of this prime factorization for 40. So we're going to do our little shortcut here and see 2 to the 3rd power, when I multiply all those together, cancels with the cube root. So I get 2 right there, okay? And then the cube root of 5 minus 2 cube root of 6. Now, you might think that, oh, well, I've got -2 and -2. I can just make this -4. That's not true. because these two terms are not like, okay? It would be no different than saying negative 2x minus 2y. You can't put those together, okay? So you just leave them like it is. So I'm going to leave that up on the screen for a second to kind of let you catch up and catch your breath. If there's any questions, just type it in the chat at the bottom. We've got one more page to do, which is only one more problem on this section. And then we'll move into our 1-4, dealing with multiplication of radicals. And it's a little bit, I'd say a little bit easier. This is pretty complicated. All right. All right, so let's move on to the last page of 1.1-3. And I'm going to brighten this up a little bit. Okay, so if you'll notice a minute ago, I had two 40s under the as a radicand, under the radical. I don't have anything that's like here, so I don't have a 48 or a 135 or a 5 to combine with anything else. So I'm pretty sure, and most everything's going to be some sort of cube root of 5 out of this, because I'm seeing a multiple of 5 here. This one may not. This is going to be different. So we're going to try and break down. Let's try and break down all of them at the same time this time. Okay. All right, I'm going to break it into 2s. All right, so I know this guy right here is not going to change. I'm sorry, that's cube root. I keep putting square root. This guy is not going to change because you can't prime factorize 5. It's already simplified as far as it'll go. 135 off the top of my head. Let's see. Let's just do the easy one and say 5. How many times will 5 go into 13? 2. 27. So this right here will be 27 right there. Okay. Now there was a chart a couple of weeks ago where it had perfect cubes, perfect squares, and so on and so on. Well, the cube root of 27 is a perfect. You might as well go ahead right now and just understand that these two things right here are perfect cubes. So what kind of perfect cubes are they? Well, the cube root of 8 is 2. All right, we'll type this in the calculator in just a minute, okay? So we've got 2 out in front here, and the cube root of 27 is 3. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. All right, and then we've got the cube root of 5 here left over. If you'll notice, that's something that we've seen before, because it was right here. These two terms right here, we're going to combine these two terms. So 6 take away 3 is going to be what we do here, right? So let's just kind of rehash what's happened here so far. So I broke 48 down into 6 times 8, and I noticed 8 was a perfect cube. 2 times 2 times 2 is 8, so that 2 comes out. This cube root of 6 stays right there, and that negative is sticky, it stays with it. So if you come over here, 135 was 5 times 27. 27 is a perfect cube because 3 times 3 times 3 is 27, and I pull that 3 out. So there was already a 2 here, then I pull out the 3, and I'm left with cube root of 5. Right? Now over here, this stayed just like it was. Now we're going to rewrite and simplify. So this part is part of your answer automatically. This part, we need to simplify out a little bit so you can see all the steps. So we're going to combine all of that because they have like terms, or like radicands underneath the radical. All right, and so you've got this negative 2 cube root of 6 plus 3 cube root of 5, and then we're done. Check mark. All right, if there's any other questions as I'm going, just type them in the chat. I will definitely stop and answer them for you, and you can follow along and write down as we go. All right, so let's go to section 1.4 now. This is what the video is going to be titled. It's going to be radicals, simplify, multiply, and rationalize. Now, we're going to take our time on this to try to understand this topic. the last topic that we did, I kind of zoomed through that second half because we had already discussed in the first video of that how to do some of that stuff. And I just want you to get used to seeing how that's done fast and efficiently, okay? So now we're going to take our time here and slow down, all right? So today we'll continue working with properties of radicals. We'll be using the product property of radicals. Product property. I'm going to circle that, okay? So the product property of radicals looks like this, and it's a lot like what we just did. We've already done it. So you remember how we did 48 with 6 times 8? Well, I've already started using the product property of radicals, okay? You've already seen this. And so this is just another way. We're just getting more practice now, okay? So one of the key skills in working with radicals is to recognize the index. Now, if you'll notice here, excuse me, if you'll notice here, our index is 2. It's an understood square root. But this index here is 4. All right, I don't know if you can see that. I'll blow that up a little bit so you can kind of visualize this. And this other index is 3. All right, that's as bright as I can get it, guys. I don't know what's going on here. All right, so one of the key skills in working with radicals is to recognize the index and how that dictates the manner in which you organize the radicand to simplify. All right, so if you'll notice here, what might be a good idea to look at is, you see how I've got 3 x's? There's really nothing you can do with that because you would need 4 x's in order to pull that out. So really, this is anything less than 4 is going to stay under the radical, okay? If anything more than 4, if you'll see I've got y to the 6th power, that means I've got 1, 2, 3, 4, 5, 6. There's 6 y's under that radical. And if you'll notice, I can pull out 4. And then once I pull out 4, that goes out in front. That y to the 4th power cancels with the 1/4 here. So 4 divided by 4 is 1. So we would pull out 1 y to the 1 power. All right, so now the index is 4. So our task is to organize the radicand. 80 x to the 3rd, y to the 6th in powers of 4. Any terms left over will remain under the radical. So you're going to leave this guy here under the radical. Now, we haven't talked about 80. Now, let's rewrite 80 x to the 3rd, y to the 4th, y to the 2nd. So this guy right here is going to be pulled out. I'm going to put the 4th root here. So when you say 4 divided by 4, that means y is going to come out front. But I'm going to hold off on that for just a minute because I want you to see what's fixing to happen with 80. And what number multiplied by itself 4 times makes 80? Well, you really need to spend some time figuring out how to break 80 down first before we get to that point. I'm going to keep circling that y to the 4th for a while, so you can, because you'll know that I'm going to pull that out, and what's left. Matter of fact, if I were on the ACT and I were simplifying this, I would go ahead and put stop right here and look at my answers, and I would know that I would have an x to the 3rd and y to the 2nd in my answers. You could go ahead, it doesn't matter what's over here. If there's only one answer that has x to the 3rd, y to the 2 under the radical, and solve it and go to the next one, all right? You need to spend as little time as possible answering ACT questions. So now we're going to spend a little bit more time simplifying out 80 is 8 times 10. So that's 2 times 2 times 2. And then 10 is 2 times 5, right? So there's probably a little bit smarter way that we could have handled this situation, because right now it really gives us a lot of too much information. We simplified 80 out into kind of the wrong. What we should have done was 16 times 5. We'll get faster with this as we go. I'm just trying to show you step by step how this works at first. So 80 is 8 times 10, 8 is 222, 10 is 2 times 5. We have 4 2's combined right here into this, and we have 4 y's combined. So that means 4 divided by 4, you pull out your 2, and that's 1 power. And then 4 divided by 4, that's y to the 1 power. Now we're still fourth rooting everything else underneath, and we have 5x to the third, y to the second, and then we're done. Okay, so that's how you answer that question there. And we're going to do the next problem the same exact way, but I'm going to try and be a little smarter about how. I'm going to see if we can skip this whole, maybe one of these two steps here and go straight to this, all right? It's probably best to go to the prime factorization at first if you're not sure what number here to remember. You always have a calculator in front of you when you're doing a test most of the time these days. But okay, so we're going to split this up. If you'll notice, I'm going to go ahead and underline the things that are going to stay under the radical. So you see how we've got n here to the 1 power. There's not enough n's to pull out, so we're going to leave n on the inside. Now m, I'm going to rewrite as m to the third, m to the second. So so when you multiply two like bases with exponents, you add the exponents. So in this case, we've got 3 m's and 2 more m's here. So what's going to stay under the radical are these two things here. This is going to move outside because 3 divided by 3 is 1. Now we're going to rewrite the number 135 in a little bit smarter way. Let's sit and think for a second what numbers multiply to make 135. Okay, 5 times 2 is 10. So we have, okay, so what happens is this is going to be 5 times 27, right? So let's go over here and look at this. So this is going to be second mode clear. All right, 5 times 27 is 135, right? Now 27 is a perfect cube because 27 is nothing more than 3 times 3 times 3, right? So that's what makes that a perfect cube, and that's why I'm going to pull, instead of prime factorizing it, I'm doing it in my head, and I'm trying to memorize that, Okay, so what I'm going to do is I'm going to leave this negative out in front, and I'm going to put 5 times 27 here. Now, this 5 is going to stay under the radical. Notice I didn't underline the negative 5 here. We'll talk about that negative in a second. But this is a perfect cube. So that's going to be pulled out. Do you know what that is? 27 is 3 cubed. The cube root of 27 is, I'm going to start pulling out stuff now, okay? 3. And then m to the third power divided by 3 is just m. And then, so that m pulls out. And then what's left underneath is now I know I'm doing this on purpose. I'm leaving that negative underneath there. And I'm putting m squared n, which is the stuff that I haven't talked about. 5m squared n, right? Because those 3 things are left under the radical. Now, this negative is important because of the cube root situation. Normally, in a square root situation, this would turn out to be a complex number which would be I. Because remember, the square root of -1 is I, with a cube root of -1 is -1. Now, the reason that is because the cube root of -1 can be raised to the third power, and it doesn't change, and 3 divided by 3 is 1. Okay, see that? That's how you can visualize this. All right, so now if you'll notice, think about this being separate, a -1 times 5. So -1 times 5 means, or the cube root of -1 means I can pull out a negative, since there's 3 negatives I can put here, and it would still work. And what's left over is this right here. So this is your final answer for this section here. So remember, I told you we're going to go a little slower on this stuff, okay? But you know, that might have been a little bit fast for some, but that's what YouTube's good for, is you can go in there and set the speed on something. If I'm going too fast, you can set the you can go to settings and then video speed, playback speed, and turn it down to like half the speed. I know I'll be, you know, it'd be like me talking like a robot, but it mean I would at least slow down enough for you to catch on to what's going on. This right here, there's a lot of things happening here. Okay, I stretched out everything I could possibly stretch out here to explain it, but I shortened up a lot of stuff, like this cube root of -1, pulling that out, and then I skipped the step of calling this 3 to the third power. 3 to the third power divided by 3 is 3, right? Or 3 to the third power raised to the 1/3 power. That's what that is. And so the 3 and the 1/3 would cancel. All right. So in this situation here, pay attention to your index. So we have 2 square roots here. Using the property of radicals, it can go both ways. So A times B becomes A times B. You see that? So what's 6 times 6? So 6 times 6 is 36, right? And then the square root of 36 should be an understood 6. Now, in this case, I'm gonna go ahead and put a plus or minus there, because you guys need to be used to seeing that here. Okay, so just remember that you can't do this. Use this symbol for every single situation. Now, this is obviously an index of 2, so that's square rooting here. So if you'll notice, I've got 2 times 18. This is a very similar situation, so it becomes 36, the square root of 36, which is 6. See that? So these two terms or expressions are equivalent. Okay. Now let's go down to the next section here and notice that our index is 4. Now we're going to be a little bit smarter about this. If you'll notice, 18 and 36 have something to do with one another. So what I'm going to do, let's see what we can do here real quick. I'm going to put the square root, the 4th root of 18, and I'm going to separate this out here into the 4th root of 2 and the 4th root of 18. If you'll notice, I've got like situation here, right? You can combine these two together. Now it might be a little more advanced, you know, a little more, too much information, but we can combine these two things together. So we can think of it like this and think of this, put these two things together. Let's see what we get. So we're going to put 5 minus, this may be exactly the wrong way to do this, but so this is kind of like distributive property. If you could pull that out, you can see what's left inside of here. So the 4th root of 18 is 18 an actual 4th root, like perfect 4th, like a perfect square or a perfect cube. 2 times 2 is 4. 4 times 2 is 16. So it can't be 2. Let's try 3. 3 times 3 is 9. 9 times 3 is 27. So it's not going to be 2 or 3. It's not going to be a nice, easy number. So, you know what? It might have been better to do this a little bit different way, but I'm going to just see if I can keep working this out. You can see how you can make kind of paint yourself into a corner with this kind of stuff. Now, the 4th root of 2 is not going to work out here. So you know what I'm going to do? I'm going to scrap this idea, and we're going to restart this problem over here to the right, and we're going to prime factorize 18. 18 is 2 times 9. So we get 2 times 3 times 3. Well, if you'll notice, there's nothing I can do with either 2 or 3 because I don't have 4 of either one of those. So we'll see how this turns out in just a second. So I think my biggest problem here a minute ago is I made a mistake here. I was thinking this was subtraction. I should have thought of this as multiplication. This is a lot easier than I just made. You can, if you go back in the video, you can see how I made the mistake here. All right. So if I were editing this, I would totally edit that out because this is just multiplication. It's straightforward, nothing to it. In this case, it's 2 times 18. And remember, we had 2 times 18 is 36. And we already did the fourth root of 18 prime factorized. So we don't have to do that twice. I'm just trying to show you the, in this case right here, I'm just going to go ahead and write this out as 4. Okay. The fourth root of 2 doesn't change. The fourth root of 18 can be spread out like this. But if you notice, there's still not 4 2s and there's still not 4 3s underneath this radical. Yeah, so, okay, so let's think of it like this. I'm going to circle this little section here, and I'm going to circle this little section here. And I'm going to rewrite this right here as a fourth root. So I'm going to keep these separated. This little section right here, okay? So we're going to, this and this are like terms, I guess, in some way. Okay, so now let's see. Remember, this is all multiplied together. So what we can do is we can actually combine, since these are all like indices here, I'm going to separate this out. And I'm going to put a big bar here for the fourth root. So we're going to put this fourth root material here, and then we're going to put this fourth root material here. So remember, it's 2 times 2 times 3 times 3, right? Now I'm seeing something come up that's 4 of that, okay? So it's, there's 4 3s, right? So there's 3 2s and 4 3s. So if I were to rewrite this, this is obviously 20 when you multiply that together. So I'm going to go ahead and take care of that. 2 to the third power is going to stay 8. So I'm going to keep that 8 just like that. Because these stay under, and I might as well go ahead and combine those. So 3 times 3 times 3 times 3 is 3 to the fourth power. 3 to the fourth power divided by 4 is 3. So I'm going to rewrite that. I'm going to take this step here, and I'm going to rewrite this in that, because I want you to understand what this actually means. 3 to the fourth raised to the fourth, 1/4 power. 4 times 1/4 is 1. So this exponent goes away, and we're left with 3 there. 20 times 3 is 60, and we have the fourth root of 8, which is done. So now we can go through and verify this with the calculator. This and this are equivalent, all right? And I know there's a couple of steps in here where I was messing around and trying to play with the numbers. I probably could have gone from this step right here straight to this step right here. I probably could have skipped that middle step there by prime factorization. And that's what I was trying to do over here. But I messed up and thought it was going to be subtraction. So it's easy to make mistakes sometimes. Sometimes the problems are a little more simple than they look. But this is equivalent to that, okay? Now, a lot of material there, a lot of information. And I know it's hard to think of a question to ask at this point because it's so complicated. But if you want me to go back over a certain section, that might be better. Even if it's on section 1.3, if you miss something on 1.3, I can go back and kind of hit the high points on that. Okay, so let's look, perform the operation and simplify. So what we're going to have here, if you'll notice, we've got an indices of 2 or index of 2. right? If you have more than one index, sometimes that happens. You call it indices, okay? So we're going to multiply these two terms and these two terms together, all right? We're going to perform the operation and simplify. So if we combine 5 and 6, that's using the product property of radicals, okay? And then 3 goes out in front, and the square root of 5 goes off to the back. This is the way most of the time you would see a irrational number written, okay, with the lowest prime radical off to the right. Now, in this case, because, okay, so we're supposed to simplify, right? So if you multiply these two things, you can't change anything to the square root of 6, and you can't change anything to the square root of 5 because those are simplified as they can possibly be. So let's, I think at this point, I'm trying to think if this if I would be just basically going backwards. I think we're pretty much wrapped up here because, well, let's see. We might be able to figure out, okay, 2 times 15, 30 is 2 times 15, right? Well, that's a large 3 there, not a little 3. Be careful there. So we've got 2 times 15 is 2 times 3 times 5. See, there's nothing we can do here. We may be already pretty much through. Just playing around with these numbers, I don't think there's anything really. I mean, obviously, we would go if we pulled out these 5s here, we would be doing nothing but kind of a circular argument. It's already this, right? There's nothing else we can do to simplify this. So we perform the operation, but is it simplified? Yeah, I think we're pretty much through here because the square root of 30, I know it looks like you could probably do something with that, but the prime factorization of 30 is 2 times 3 times 5. You would need 2 of something in order to pull out, 2 squared divided by 2, but you don't have that. So really, this and this are non-essential steps. I think we're through here, okay? All right, let's go over here to the right and do the same thing, distributive property. Remember, we're square rooting here. So this is 2 times the square root of 10. There's nothing special you can do with that right now. And then this right here is the product property of radicals, which is going to be the square root of 20, okay? 10 times 2 is 20, so that multiplies underneath. Now, let's see what happens when we do the prime factorization on both of these, if anything can change. If you'll notice, 10 is 2 times 5, right? So there's nothing you can do with that. That's locked into place. We got to keep that. All right, now let's look at 20. 20 is 2 times 10, which is 2 times 5, right? So we've got 2 times 2, which is 4. That's a perfect square. The square root of 4 is 2. 2 to the 2 power divided by 2 is 2. Now, so the final answer is going to be 2 square root of 5. And this is the simplest you can possibly make it. Now, theoretically, you could pull out the 2's technically and say square root of 10 plus square root of 5, but that's kind of superfluous. So you don't really need that. I think the simplest version would be this right here, okay? So now let's move on down. Now we're out of time, and I'm going to go ahead and shut it off right there. I think that this would be a good place to stop, and we'll finish up on 1-4 tomorrow, or Monday, whichever day we get to it. So we'll see how this goes because I missed yesterday. But I'm going to pause right there. If there are any questions before we leave, type them in the chat, and I'll be patient with you. If I need to go back over any little section, I will. Okay. All right. So if there's no questions, I'm going to go ahead and shut it off, and y'all have a good day, guys.